All right, 5 pass. Should we get started? I don't think we got to go for the 10 pass
No, we do
necessarily.
not.
All right. Welcome, everybody. I would like to just get started with a little framing of about the workshop. For the participants, there is a login a sign in where you could give some information about yourself. And we'd be happy to keep in touch with you. So why this workshop? What was our idea for this workshop? And this is definitely the team that I work with of undergrads at Berkeley. We've been teaching our class a couple semesters. We've been searching the web for inspiration, and we wanted to bring some different professors who are teaching in this data science and economics space together. We wanted to show what people are doing in the area of undergrad economics with data science. There's a lot of really cool materials out there, and some of it's just like, let's gather some cool materials. Let's create a repository that shares materials. Certainly, the people from Quantico are here, and they have some of the most amazing materials curated on their website, for sure. But we also just want to bring people together. It's a virtual world. It's relatively cost-free to gather people. So in the interest of sort of creating community in the time of isolation, wanted to bring people together who are doing similar stuff where they might be on different parts of the planet. This is just a great expression of interest. People who signed up for the workshop from 13 countries, 48 cities, 16 time zones, mostly people who work in education, mostly people in economics, but also people in data science, computer science. So some of this data is here for the presenters who will be talking to think about your audience. It's mostly econ professors, but people who are just generally interested in education and data science are our network who we were reaching out to. And how this is going to flow, we begin with a few talks from UC Berkeley, Brad DeLong, Conrad Miller from the business school, and myself. And then we will have 45 minutes from Quanticon, who has 5 different presenters. I see that Bertel is here, whereas I had scratched your name, so I'll put it back on. I'm glad you're feeling better.
I'm feeling better, yeah.
Okay, great, welcome. And then we have Gregory Bruitz from Harvard and Sean McCohen, who teaches for Coursera. And then finally, we have Anastasia Boris from Goldman Sachs. And at the end, we'll have some time for general discussion, and people can potentially ask us questions about the notebooks or different ideas about how we could sort of expand the reach of this approach. Okay, so what else I want to start with, there's a huge demand among the students, right? So I can talk about this a little bit in my own talk, but I will say I asked for some information from Data Science Advising. And they said out of 950 declared data science majors, 164 are in the domain emphasis for economics, which is 17% of all the majors in data science. Of the people who are double majors, 173 are double majors between data science and economics, which is 40% of the students doing double majors. And there's also a minor. So out of 585 students in the minor, 142 of them are economics majors with a data science minor. Economics is the most common major in the data science minor, representing 24% of the data science minors. So it's really popular. And I will just also say, like, UC Berkeley hasn't necessarily made it so that you have to sign up for certain tracks or other. Like, it's open. You can sign up for the data science major and pick your track. You can sign up for the data science minor and pick your track. So it's free for people to choose, and a lot of people are choosing this space, this intersection space. A lot of interest in the students, and it's growing. You know, so let's just say this minor has only been open for a year and a half, and the major has only been open for 2.5 years. So these are sort of incredible numbers for growth, like almost overnight, of the number of people. So economists would be like, there's a serious latent demand that was waiting to be expressed when this market opened. And I'm going to get back to this slide again in my talk, but I just wanted to say there is a bunch of different places in the economics department and ag econ department and the business school where data science has started to come in. This isn't coordinated. These are all different professors finding different ways to teach in data science in different classes. But amazingly, people are getting to this, in many different pathways. The next step for us that we're interested in, the core staff, and the students that I work with, is changing the econometrics class, the required statistics method class that every major has to take. And so next semester, this is going to be taught with Jupyter Python. It'll be a pull, but we think that we can do it. And we think that it's a very pro-student move for a lot of reasons. I also could just point out some of these names. Brad DeLong's on here. Ted Miguel's on here, who I had worked on before. I can talk to him about that. Several classes in Ag Econ. Ag Econ has already switched to teach their econometrics class in Jupyter R. Conrad Miller's here, my class on the bottom. So you'll hear from some of these people. So just stepping back for a little bit about the inspiration, why Jupyter? Why does Jupyter allow us to make awesome new curriculum? So one thing is the textbook. It allows us to make textbooks that are built from Jupyter notebooks that are sort of alive. They can be refreshed. They can be changed. Every semester, you can update them as you go. So it's not like the in-print version of the 4th edition, right? It's changing the notebook to be a living document. They're a lot more interactive, so giving students the chance to play around with more. You can have a textbook that students can play around with. You can have a textbook, and this is certainly what the Quanticon delivers lectures, but you can download the lectures and change everything in the lecture that you want to do. That's a new paradigm in interactivity. And finally, it's all about data, right? So instead of just being like lecturing with lecture notes with, formulas, let's bring data forward in the process and have students looking at data be part of how they're learning economics. Jupyter's a platform, right? It's just like a file format in some ways. It's a way to deliver things, but we can introduce all these free software packages. In Berkeley, students start with NumPy and Matplotlib and then move on to Pandas. And we can talk about like what's the right time or the right place to get students into different packages. A lot of what econometrics is doing is in stats models, which is basically reproducing most of what R does for Python over time. You can do, all the most powerful tools in machine learning are at your fingertips. And then we will also see a bunch of stuff today in symbolic Python, what would have been previously done in MATLAB or Mathematica with mathematical formulas, that you can solve and represent equations. And certainly having these all be free and all be sort of interoperable in a single file format is really liberating, right? It's not like this class will be taught in MATLAB. This class will follow, Mathematica. Like all of these tools can come into a single notebook. So this photo here is the photo that we usually show for Data 8, this huge class that became very, very popular. That was the introduction to data science. That was where our starting point was. But what I also like to look at this picture is you can see that one way to think about it is all the students can have their notebooks out If every student in this giant lecture hall can be executing the same code as the professor at the same time, this is a really powerful difference, right? This isn't like the professor necessarily saying, you know, regress X against Y, watch me in a slide present a result. This is like every student in their seat can be executing that result that the professor is executing. So this is a combination of free software, cloud-based computing, open servers, open APIs, and file formats that allow us to exchange things. One more pitch that I always have to put into my talks is for reproducibility. There has been, you know, a crisis in recent years about reproducibility in social science. There's an advent of practices around reproducibility. This is an awesome thing that if we can teach Jupyter as a teaching tool, we're also teaching elements of reproducible practices through our pedagogy. The students in Data 8 do not know that the Jupyter Notebook was made for reproducible science, but they're learning to use the practice of reproducible science in their Data 8 class. There's also a lot of the advantages for reproducible science, like the people discovering the supernova and doing the analysis of the super telescope. There's advantages that they've built into sharing notebooks that are also really great for sharing curriculum and sharing between professor and student and making sure that the code executes in every student's window exactly the same way. There's also for our class and for economics generally a practice of teaching through reproducing journal articles, taking seminal journal articles and reproducing the graph or reproducing the econometrics. And that is really possible in a way that's never been possible before. Like, you know, certain projects in our class are basically like take a data set, reproduce it, at least some elements of what happens in a journal article. You probably can't do the most complicated part of it, but you can do some basic elements. And so like teaching off of seminal articles as your assignments is, you know, is sort of an amazing innovation. Okay, I want to jump really quick to the people out there in the audience to get you to try out the Workshop Data Hub. If you go to workshop.datahub.berkeley.edu, you will then need a login and a password. You can log in with your email and use the same common password for everyone, which is correct horse battery staple. In the green.
How many passwords are correct horse battery staple now in the world?
I don't know, but I always been using the same one for a couple years. It's probably time for me to change it. I think the idea of correct horse battery staple is having a 20-character password is safer than having a 7-character password, whether it has all the symbols and numbers that you could put in it.
But having one that was blasted out to the entire world by, I think, XKCD.
Right.
Yes.
All right. We should change it. But for now, we can just go in our Jupyter Hub and see how much it's being abused. And it turns out that it's not being abused.
Touche.
So we have telemetry to tell us whether it's a problem or not. You know, we basically want everybody who wants to try out Jupyter Hub to try it out. Okay, so what you would do is go and log in. Make sure that you get into the Jupyter Hub, and then you can switch tabs back to the website for this conference, which will have a resources tab all the way on the right. And if you go down, it will have the notebooks, some of the notebooks that we'll be talking about today. Some of them might just pull out to Binder, some of them might just pull out to Quantico directly, but a few of the key ones will open in that workshop hub, and you can see what it'd be like for a student to be in homework 1 or lab 4 or whatever it will be. Can we see our what's it called? The Q&A channel? Anybody in the Q&A channel can tell me if you've logged into the workshop hub?
Yeah, people are logging in.
Mine has too many things because I've taught too many workshops, but if you're attending, this will be completely blank. All right, I can do a demo of the process. Let me log out. All right, so when I first come, this is what it will look like. I will type my email and correct horse battery staple there. Then I will click sign in. I will get a bunch of files in my directory tree that you will not see. Okay, good. You logged in, but you don't see files. You're in the right place. Then I will go back to the workshop website. I will click this resources tab on the, and if I want to see the one from Harvard, I will click on Project 1, Stories from the Atlas. And this is a magic thing where this now goes to GitHub and pulls the files from GitHub into your data hub, and now it should open. Okay, anybody in the Q&A? Did that work for everyone? Okay, we are good. Let's I'm ready to go to Brad DeLong when Brad DeLong's ready.
I'm ready.
Okay, so I'm going to stop sharing and let you share.
Okay. See, I have too many screens.
That
I
happened.
need to be a co-host in order to share a screen.
Oh, you should be able to share, no?
Host is disabled screen sharing.
Oh my God.
Yes. Okay, let's try it again.
All right, your co-host. Is that working now?
Okay, let's try. And it seems to be good for me, at least.
Yep, looks good.
Does it look good for you? All right, so I got into this business. I got into this business when somebody, I forget who, told me that what I really should do is go look at Sargent and Stikursky's Quantico. That it was wonderful and it was amazing. And that especially at Berkeley, it would be even more wonderful and amazing for us, given that we appeared to be becoming Jupyter Python central for the known universe. That is, if it was already in Python, there were at least 100 experts within 1 mile of the center of the Berkeley campus who knew about it. And if it wasn't yet in Python, there were at least 5 people on the Berkeley campus attempting to bring it into Python right now. And that the energy involved in this particular open source ecosystem was amazing. And that Sargent and Stikursky had already put up a wonderful set of materials for it. And so I went and I looked and I agreed. And it seemed to me to be that my problem sets before had been kind of state-of-the-art information technology for the 1700s. Paper and pencil and Greek symbols and solving equations. and then having students present you with equations, and maybe there'd be a case where you'd solve for a numerical answer. And I found a lot of people who could do the problem sets didn't really understand what an exponential explosion or an exponential convergence process was in their bones, what it looked like. And then there were a bunch of students who understood what it looked like, but who really couldn't do the algebra, couldn't produce the right answers in problem sets. As a number of my students told me, it seemed that in economics, we were going through things 3 different ways. Everything we were going through 3 ways. We were going through it in words and paragraphs and causal chains. We were going through it in graphs and figures, and we were going through it in equations. And these all 3 were supposed to reinforce each other. That the graphs and equations were kind of geometric representations of the equations, and the equations were algebraic representations of the words and the causal processes. And so hopefully you would go around the circle and gain deep insight by having 3 different mental modes to look at what was actually being taught, analyzed, discussed. But for most of our students, it didn't work that way. For most of our students, they either got the equations, got the analytic geometry, got the words, and the other 2 were some strange academic ritual we were requiring them to perform. So I got, and I think all of you have gotten, perfectly wonderful paragraphs explaining what is going on, and then the graph off to the side is total nonsense. Or the graph is excellent, but they don't know what it means, or the equation is right, but then the time does not work. It seemed that this was an incredible opportunity to leverage our growing computer power, to actually make people feel in their bones what model economies would do. And indeed to bring us to a place where computers would be our servants, and where you wouldn't have to be able to stare at an equation and then see the process over time in your mind's eye to really understand something. And so I began shifting my problem sets into Python Jupyter notebooks, and I think it went very well, because the undergraduate courses I was then teaching were the upper track macro theory courses, in which most of the students are coming over from applied math and engineering. And they take to the math and they took to the programming like ducks to water. But then things shifted. There was a demand that we teach American economic history again that I was bored with. And I said, well, no, what I really want to do is steal Melissa Dell's History of Economic Growth from Harvard and do some growth modeling, some growth analytics, some growth history, reaching all the way back to the Neolithic Revolution. And now I find I have a group of students who are, instead of 2/3 of them having had a semester of programming experience before, only 1/4 of them have. And instead of having students, having the modal student having gone through 3 semesters of calculus before they show up, the modal student has only gone through 1. And then there's the Berkeley economics problem with statistics. That is, we have gotten ourselves into we have screwed the pooch in 2 different ways. One way is that there are a bunch of people who are on scholarships that require that they maintain minimum grade point averages. And because they are paranoid, that means they are all trying to maximize their grade point average here and now as their first lexicographic priority. And the second is that we condition admission on to the major on maintaining a high grade point average. And the average grades in our econometrics courses are relatively low, which means that we've gotten ourselves in an equilibrium in which because econometrics is a hard course that is graded harshly. Virtually nobody takes econometrics until their senior year, by which time it's too late for it to be of any good in use as far as other courses are concerned. And then once we were in this equilibrium, there were, of course, no extra seats in econometrics for anyone not a senior, because the seniors all needed it to graduate, and we did not have excess capacity in the system. So right now we are doubling and tripling up on how many econometrics courses we teach in order to deal with the backlog and trying to get people into a good equilibrium. But in the meantime, even the people who in a normal curriculum would have seen their econometrics before don't really have it, which makes it an absolute bastard to try to use. In the remaining amount of my time, what I want to talk about is what I am actually trying to do right now for this socially distanced, virtual, online, 150-person class on economic growth, taking one of the Stekursky-Sargent problem sets and trying to pull out of it things that are useful in teaching and also useful for gaining students' experience when they do not have much experience in Python and have next to no formal knowledge of statistics. So what I'm doing right now is I'm taking the governance and prosperity paper from Ashimoglu, Johnson, and Robinson, settler mortality and institutions and current prosperity. And I am taking what Sargent and Stekursky did to create this particular problem set and pulling pieces out from it that I can then use to produce a problem set / lecture / lesson that I hope will be useful to my group of undergraduates. As you probably remember, and as Stekursky and Sargent lead you through on Quant Econ, Ashimoglu, Johnson, and Robinson got a measure of the perceived quality of governance from Political Risk Services, a qualitative measure, and got log income per capita in 1995 and plotted the scatter for non-European countries, for countries that had been colonized, either settler colonies or others, and found this nice, very strong relationship. R of 0.5, and bivariate R of 0.5, the slope coefficient of 0.5 as well. But of course, there was the question of effect or cause and effect. What is going on here? Is it that those countries that have good institutions and secure property rights now, is that causing their prosperity? Or is their prosperity and the general fact that a prosperous country is one in which a lot of things are working? Well, if we know a lot of things are working because it's prosperous, doesn't that mean that either directly, because prosperity creates a demand for high quality governance, or indirectly, because the factors that make the institutions that produce prosperity work also make governance work? Is it cause or is it effect? And so I'm trying to write words right now that will lead them through these particular kind of econometric causal issues. And then having done that, I'm going to actually have the students do something concrete rather than just reproducing what I'm doing, by asking them to calculate and tell me what difference it makes with this OLS scatter if we move from a perceived quality of governance of 6 to one of 8 to one of 10. What does it really mean to go to a log income per capita in 1995 of 8 annually to one of 9 to one of 10? in which case they then have to do a very, very little bit of Python programming, using Python only as a scratch pad, as something for which they would otherwise use Excel if they knew Excel, and some of them do and most of them do not. But I am desperate to wean them off of Excel because Excel is basically two-dimensional assembly language programming without any audit trail. And you use Excel for anything, you're going to make mistakes, and then you're going to be completely unable to correct those mistakes. So I'm going to ask them to be doing simple things, to simply write one small loop, to have that loop run through the governance qualities from 4 to 10 and say, what does this particular scatter and the associated relationship tell you about what happens to a country as it moves from equality of governments to Haiti? You know, what level of income per capita is associated with governance at the level of Haiti, all the way up to Canada. And that's doable. I'm confident that will be useful to them. I'm confident that that will work for them. But then there are the other deeper things that I want to do. That is, we have our question of which is cause, and which is effect. How much of our scatter is a positive relationship governed by the parameter beta, by which a better level of governance produces higher level of prosperity in terms of log output per capita? And how much of it is reverse causation coming backwards from prosperity or the other things that produce prosperity, giving you better governance? Well, we all know that the regression coefficient that we get out from an OLS regression is going to be a weighted average of beta of the causal relationship from quality of governments to output, and of 1 over gamma, where gamma is the coefficient from prosperity back to governance. We're going to have this weighted average. How this weighted average produces, what this weighted average produces for beta, given gamma, and given the variance ratio of the shocks to the system we have, well, it very much depends, that our regression coefficient of 0.5 can be associated with an awfully large number of kind of betas. For a strong relationship, going back the other way, from prosperity to governance, if we have a high variance ratio in the shocks, so that almost all of the movement is along this upward sloping governance causes prosperity curve, we do indeed manage to recover in our OLS scatter something very close to the OLS coefficient. But as the variance ratio drops, so that more of the variation is along the other dimension, is along kind of prosperity causing governance. If there's a strong relationship there, then in order to get a 0.5 for your estimated regression coefficient, you need to have a larger and larger and stronger true relationship between governance and prosperity in the causal direction, because a lot of it is being masked by this reverse causation coming back the other way. The rubber hits the road when we move from the basic AJR scatter to their claim that settler mortality early in the age of imperialism is a valid instrument for governance quality today. And so then we have the scatter and the regression of expected quality of governance today, given reported settler mortality early in the age of imperialism, and log income per capita. and their regression coefficient roughly doubles. Their regression coefficient roughly doubles, strongly suggesting that the 1 over gamma is going to be kind of quite large, because you have your estimate of what the true regression coefficient is. If you have a valid instrument of 1, you have your OLS regression coefficient of 0.5. The true coefficient is a weighted average of the true beta, or the estimated regression coefficient is the weighted average of the true beta and 1 over the gamma coming back the other way. That tells you that 1 over gamma is going to have to be quite big in order to have an observed 0.5 as your estimate, as what we actually estimate from the OLS scatter. And that means that somewhere out there in the causal universe, right, say, in order to have your basic estimated scatter of 0.5, a true regression coefficient up here of 1, this a weighted average of these two, large reverse causation in a negative way, by which prosperity tends to make your governance of lower quality. And so that the Japans, the Canadas, the New Zealands, the Australias, they really ought, given their quality of governance, to be a lot more prosperous than they are, save that a whole bunch of that correlation is being masked by this negative reverse correlation coming back the other way, by which the fact that they're prosperous has led to a degradation in their quality of their governance. And Asimoglu, Johnson, and Robinson, although they say they have a valid instrument, and they certainly have impressive statistical results, they really do not have a story about why it is that the other part of the causal nexus in your complete model, if they were to write it down, would be going the other way, would be going from high prosperity to inferior governance. And then I'm going to want them to take that and say, okay, let's go back and try to figure out whether settler mortality early in the age of imperialism is in fact a valid instrument for what's going on with kind of prosperity and with governance and prosperity today. It will be a heavy lift. I think there's a 50% chance I'll be able to accomplish it by Saturday when I have to send out the problem set. If not, I have another one that's much more boring and reserved to send out. But it will cause them to run a bunch of regressions in Python. It will cause them, even those who haven't had statistics before, to go to the regression result tables and pick out numbers. It hopefully will make them understand what the difference between a log income per capita of 6 and a log income per capita of 10 is in a deeper level. And I hope it'll make them better critics of statistical results when they're brought in front of them in the future. That's where I am right now. I find myself really, really wishing that the students had a semester of statistics and also a semester of programming in high school, or at least that it were required of freshmen to give them the base for this. Because moving problem sets into Python is a true joy. When the students I had were largely applied math and econ majors who were choosing the math intensive econ track. When I have this other much broader bunch of students, even Berkeley students, it feels much more like a high wire act without a net. And let me stop there, and let me again, for those who have come in late, say that I do indeed feel like a dwarf standing on the shoulders of giants here, with the giants being John Stikursky and Thomas Sargent.
Awesome. Thank you, Brad.
You're welcome.
I think that was a little view into like what it's like being the professor trying to make the problem set before you send it out.
Mhm.
And I just want to say we want to work together with you to get this the ambient level of Berkeley Econ students up a little bit. So
But a lot of these aren't econ students. A lot of these are political science,
political economy,
history students, and political economy. Plus John Steinson, who has taken the upper level macro math theory track course away from me, is also the vice chair who wants this course qualified as a history distribution requirement course for the university as a whole to attract even more students who are not STEM majors into it.
Well, there's multiple fronts that we need to battle on, but
Yes.
more statistical and Python literacy will be important. Love to move on to Conrad Miller from Haas Business School, who we've been working with for a few years and really just came from data science over to the university. Is that fair to say, Conrad? You were a data scientist as an intervening career choice?
I would say I took a data science pit stop.
Data science pit stop.
Econ before, econ after. So.
All right. Well, he made some incredible materials that really, before my class ever started, was just like a great vision of like, how do you take a student in Data 8 and take them on an adventure off into economics and economic inquiry at that beginning level?
Okay, let me get started here.
You're good.
I'm good. Great. So thanks for the intro, Eric. So I teach undergrads in the business school a course called Data and Decisions, which is an introductory causal inference course with about 100 students. Just to give you a sense of the kind of the level content of the course, we use the undergrad version of Angress and Pischke's Mostly Harmless Econometrics as our textbook, so their book Mastering Metrics. So that covers topics like potential outcomes framework, randomized experiments, some matching, regression discontinuity, differences and differences. So this is a course that is one path for our undergrad applicants to the business program. It's one way they can satisfy our stats prerequisite. So we get a pretty broad, I think, spectrum of students in terms of their background. A good share of them are interested in applying to the business program, but not all of them. And the students apply to the business program at Haas, at Berkeley in their sophomore year. So we have mostly sophomores, but then a mix of freshmen and upperclassmen as well. One, I think, just in listening to Brad talk about his preferences for student preparation, one, I think, great advantage of my course, at least from the perspective of my perspective, the perspective of the instructor, is that my course is what's called a connector course at Berkeley, which means that basically all of my students have either already taken this Data 8 introductory data science course that Eric showed you a photo of the lecture hall for, or they're taking it concurrently with my course. And so what's really nice about that is basically I rely entirely on that Data 8, this core data science class, to teach students some basic Python, comfort with the Jupyter notebooks, as well as some introductory statistics. So I can really I really don't teach any programming at all in my class. There's some kind of informal teaching that happens in labs in our class. But otherwise, I don't devote any lecture to that material. I can just kind of take it as given that they've had some exposure to it, and also rely on the fact that students can help each other a lot in working on labs and problem sets, because they've all seen the programming material already. Should also say, so this is a pretty non-technical course, so most of the students I suspect won't take another statistics class after this one, but my goal is really just to give them a taste for how important kind of causal questions can be, and how easily we can get the answers to those questions wrong. So in terms of how we use the Jupyter notebooks in Python in our course, so we have the lecture. I don't really kind of go through notebooks directly in lecture, more kind of traditional lecture. Then the problem sets are all in Python, and then we have labs for about half of the lecture, in-class labs that are all in Python, and I'll talk through a couple of the labs in a second for this course. So I think one really nice advantage of using this kind of Python sandbox that's set up by Data 8 from my perspective is, so mainly my course is teaching these different methodological approaches to answering causal questions. So we talk a lot about experiments. We also talk about observational approaches to doing causal inference. And I think for the kind of course I took, we would, in an econometric sequence, we would learn some stata, and we'd learn commands and stata that would allow us to implement whatever procedure was introduced in class. But what's really easy for me to do in my setup is I can actually, at a pretty low level, I can have them actually code up estimators themselves. And I think that really gives people a lot more intuition for what these different approaches are doing. And in my class, they're pretty simple. Matching, you can explain matching, but I think even though it sounds really simple to explain, actually just having people code up, what would an actual matching estimator do? What are we doing with our data in coming up with these estimators? I think this kind of approach is really useful for making that intuitive for students. So I want to talk just briefly about an example of one lab in my course. So I think we posted two labs for my course, Lab 4 and Lab 5. I'm going to talk through basically I put together a notebook that's a hybrid of those two labs, both 4 and 5. They're both kind of using the same data set, just to give you a flavor for what kinds of things we do in our class. So in this is a lab where we're going through an academic paper, actually going through a political science paper by, Arsenault, Gerber, and Green from 2006. And it's a great, I think, genre of paper for this kind of class, because the basic setup is the researchers are analyzing some randomized experiment, and then they're comparing, what answer do you get to some causal question with an experiment to compare that answer to the answer you'd get if you pretended you didn't have an experiment and you just applied the observational approaches that we would discuss in class. So in this case, we'll have an experiment, and actually I don't tell them at the beginning of, when we introduce this lab, I don't tell them the data is from an experiment. I just say, here are the data. We're interested in answering this question. Let's try applying these observational methods we've learned, in particular just matching and regression. And then at the end, there's the big reveal is, actually, this was an experiment. We can do the kind of more straightforward, credible thing, and then compare the answers we get. So in this case, in this experiment, it's analyzing the effectiveness of a get out the vote campaign for 2002 midterm elections. And it's using data from this get out the vote campaign in I believe, Iowa and Michigan. And so it's just a campaign where they called potential voters, encouraging them to vote. And then what we're interested in is whether they actually vote in this 2002 election. Okay, so the causal question is just, is this campaign actually increasing turnout? So just to begin with, we get the actual data from this paper, and I give them some subset of the data here. So we just have a simple table here where for all these potential voters, we'll know whether they were actually contacted by this Get Out the Vote campaign, their voting history, some basic demographic characteristics, and then and then whether they actually vote in the 2002 election. So I just give them data, they play around with it, do some warm-ups where they just give me some descriptive statistics. For example, on the percentage of, what percentage of voters in our data set were contacted, for example. So I'm gonna just scroll here to our kind of first, actual implementation of, first attempt at trying to answer the causal question we're interested in here. So this lab we do right after I've introduced matching in lecture. And so we try and build towards kind of constructing a matching estimator using just very basic, some very basic Python here. So the way we build up to that is we just say, okay, let's build a function where you give me an input. So let's say we want to match on age, and I want to find two potential voters, the same age, one that was contacted, one that wasn't. So we just write a function here where, let's see. So I have them write a function here where it takes as an input the age, and then it's going to spit out some random row of a potential voter with that age. And they build up from that. So you get some intuition for kind of what this function is doing, test it out, give them some sense for the fact that, okay, with this approach, with every run, we're actually going to get a different match. You can compare your result to your neighbor, get some sense for, how this approach might be a little, is going to be sensitive to your particular draw. We build from that, match on a bunch of different characteristics. Let's see down here. Yeah, so we can match on a bunch of characteristics at once. And then they build from there a function where you're going to take some table for a bunch of potential voters, and then it's going to spit out a table of all of your matched voters. So for example, I'll give you a table of all of the contacted voters, and then this function is going to spit out a corresponding table of non-contacted voters that have the same kind of distribution of characteristics. So I believe, yeah, that's what's going on here in this question 3.3. So use this function you built to create a table of matched non-contacted voters. So we can do something like that, and then they can use that to get one answer to this question. If we just match on observables, compare turnout rates for contacted versus non-contacted, that's going to give us some estimate for what's the effect of this get out the vote campaign. Next thing I'll just briefly touch on here. So we can take a regression approach to that same question. And what's, I think, nice here for teaching regression, we can actually, rather than just using some kind of regression package, we actually have them build a function that gives them the sum of squares, and then they can minimize that function to actually, so they get some sense for what this is actually doing. Then they can compare that output to what we got with matching. And then at the very end, we reveal, okay, actually, we had a randomized experiment here. So let's do what we learned earlier on in the classes, which is how do we evaluate an experiment with non-compliance? Because here, you can be randomized into receiving a call, but that doesn't mean you'll necessarily pick up the phone. So we try analyzing the experiment as an experiment with non-compliance, compare that answer to what we get with the observational methods. And actually, in this case, we find we get pretty different answers. So it gives students some sense of how some of these approaches might not always work. And then we give a ton of other examples in the course of that kind of flavor. I think I've said what I want to say there, so I'll leave it there.
Nice. Thank you, Conrad. All right, I'm going to jump over to our class, which is similarly a connector class that came after, a few years after Conrad's. I want to talk about our class that we built over the last couple of years, and sort of similarly, it's this idea of a connector class where you're in data 8, but you're also taking another class. And we had the idea here to make sort of the tools that an econ major might want to know on their way towards enjoying a class like Brad DeLong's class in the upper division. So I'm going to talk just a little bit about data science at Berkeley, because that's another hat that I wear. It's another part of my job about the modules and the connectors. Then I'll talk about this connector class that we built, and a little bit about other tools if you are econ professor and you're interested in some of the other stuff. So really quickly, this big project started in 2015 with this huge class data 8 that we've been talking about. So massive growth since 2015, and now there's 3,000 students per year going through data 8. And this is pretty diverse. Like, the class is made so that anybody can come in with no math prerequisite, no computer science prerequisite, and just can come and sort of, it's really taught in a great way that feels inclusive to people. So there's over 35 majors in any given offering of data 8. Ancillarily, next to data 8, we built a set of classes called connector classes, a 2-unit seminar out in the domain fields where you could take the tools that you were learning in data 8 and also learn something like Conrad Illustrated or geography, cognitive science, psychology, earthquakes, lots of different applications of the data 8 tool set. They also build this giant university-wide data hub, which also meant that we could make what's called data science modules, where we fit in small little bits of homework into other people's classes. So once the infrastructure is there, it's really easy to for the additional nth teacher to teach using this approach as well. What's really important for me to explain is how much the undergrad students have been at the core of this effort, right? Students are helping build the curriculum. Students are lab assistants and connector assistants in the connectors. In the data 8 class that has 1,500 people in it each semester, there's something like a core staff of 150 people. That's undergrad students helping with labs, undergrads helping with sections, undergrads, doing extra office hours, and that support is part of the success. But it's really empowering because we're giving the ability of the students to sort of help make the curriculum. And this has been hugely successful. As I said already, there's over 900 students in the major, over 500 in the minor, and a lot of these double majors. So really fervent area that the students are really excited about. The modules are a project that I work on largely, and that's a lot of how I got started here. I was reaching out to Brad DeLong because he had started teaching with Jupyter Notebooks in his class, but we work across campus. So there's an incredible repository of notebooks. If any of you all are interested, GitHub ds-modules. So we're building out in political science, earthquakes, public health, global studies, lots and lots of different classes across campus we're building out, because it's really easy for new students to come and do interactive compute because this infrastructure is there for them. And again, I'm just coming into this on the shoulders of incredible numbers of students that have come before us and contributed one notebook at a time, but then it gets built into a library that's across the university of so many different classes being taught. As I said before, we had different efforts in economics. So Ted Miguel started putting RStudio into his class where it was Stata before. Brian Graham was already teaching in Python. Brad DeLong had found an ambitious student to help him teach the 100B in Python, and now it's teaching 115. So Brad's moved around a little. R is being taught in several of the classes. As I said, environmental economics, their econometrics class has moved to be taught in Jupyter R. Many different professors are just sort of experimenting and trying out what it would be like to have these interactive parts of their class, like sub out 1 or 2 homeworks or sub out, a project. So finally, oh, here's what it looks like. So this is just, instead of the students needing to, in a large class with it where the GSIs might be tapped, it's really pro GSI to have this launching the data science compute in the browser. And basically in this class, we're taking, a homework that was distribute a PDF file, have the students run it in Stata, post their code into Word, upload from Word, right? So now the whole thing is in an RMD file. What you distribute's in an RMD file, the code you executes in the RMD file, and they can upload the RMD file or the knit PDF, which is even more elegant. So this is all like one single file that, the homework was previously multiple files. And it's really pro GSI because it's a lot smoother using this cloud-based compute to do it. So how we got to data 88, the idea was how to get students who are interested in data science and economics to work on a class with me. I gave them some of these ideas of what was some examples of what we had so far, and gathered a group of students, and they really came together to make this. You can see on the right we were sort of able to just, as we taught the class, use elements of the notebooks that we were teaching from to make sort of like basic textbook elements. This is somewhere between Econ 1 and Econ 100. So it's like at a freshman level, very simple level. If you want to check out our class, here's the URL for the class website that links to the textbook as well. So what were the goals of Data 8? First was connecting data science and economics. So we had a lot of students in both places. So let's teach Econ 1, Econ 100 concepts through real world data. Let's use data science tools and techniques. Let's use NumPy. Let's use, as Conrad just illustrated, where students make, the tools of the data statistical analysis as the course of the problem set. Let's, where we're going to sort and pull and make little functions to do what we need to do the analysis. We also wanted to put some motivation on econometrics. So most students go through Econ 1 and Econ 100 and then get to econometrics, and then you're just thrown into here you're going to need to learn all the statistics. So we wanted to have some ability to motivate econometrics before people took econometrics. The other part that we do is sort of showcase different parts of economics. So when you're in Econ 1, Econ 100, you don't necessarily see the different fields that you see in upper division classes. So we replicate some key, papers from labor economics, from macroeconomics, behavioral finance. So we have a little survey of things that we're going to learn in upper division classes. And then we bring in some guest lectures at the end to sort of show what some career pathways. We bring in a PhD student and somebody from industry to talk about how these things could be applied in the jobs. We also teach students skills that we think would benefit them in upper division classes. So learning LaTeX, a lot of your options are write it by hand or write it in LaTeX. So we sort of had the idea of let's expose the freshman and sophomore to writing formulas in LaTeX. If they're taking a lot of upper division econ classes, they might be ready to. And it's just sort of the idea of how to read economics literature, what it means to reproduce things from the economics literature. Basically, as I was just saying, the class is divided into two parts. We start out with Econ 1, Econ 100 concepts, supply and demand, elasticities, taxes, production, utility, basic concepts that are in any econ textbook. And then after the middle of the semester, we go and do one-off lectures, development, finance, econometrics, behavioral, inequality, game theory, and macro. So we have labs and homeworks that do a little exploration at each of these upper division topics. So the content, just to think through what the content for this class is. So it's a 2-unit class. It's a 2-hour lecture each week. We basically have a lecture where we go through the economic concepts. So we have lots of data science students that might not know the economics. So we have to be sure to teach the economics concept as well. But when we're in our lectures, we will be referencing the notebooks. And then at the end of basically the lecture will segue into a lab. So every week there's a lab that goes along with the lecture, and we start that during class, and it's a little bit longer. So we get into the topic during class, and then we hand it off, and they finish up the lab for the rest of the week. Then there's a couple longer projects that are, more in-depth exploration. Those will take 2 weeks. They're usually based on reproducing something from a paper or using a data set from a paper. So yeah, this semester, I think there were 5 bigger projects. And then finally, there's a textbook. I think Quantico will talk about this a little bit more, but you compile from Jupyter notebooks and make a Jupyter book. We have been able to sort of rapidly change the textbook each semester. It makes it free and online for the students, so they don't have to pay anything for the class. And it makes it really easy to sort of build it in real time. I just want to give a shout out again to the students, many of whom are here, who have been lecturing, building notebooks. They've been doing the grading. They've been all sorts of leaning into creating the content and teaching it for the class. And it's been a great experience for them. So for them as students, it's been a really fulfilling experience to be part of this class and get to be part of creating something. And every semester, we've had a few more students sign up than the semester before. So we know that some students are liking it. It's a little bit hard because it's not necessarily a prereq for anything yet. So students are taking it out of interest, not because it necessarily satisfies a pathway. And here's just some nice examples of different visualizations that you could be like, these could be in your Econ 1 or Econ 100 textbook. Some of these are borrowed from other places. The first graph is from a module that we made for Environmental Economics 147, and they had a summation of the California energy market. So this is a nice supply demand for energy in California. It's a little bit out of date, but it still makes a nice graph. The second one is comparing inequality in different countries. The third one across the top is motivating regression. And that's part of the textbook. That's an example that was in, it's been in multiple different sort of like how to motivate a OLS approach, but using the IPy widget sliders, which are a really nice way if you want to work in Jupyter Notebooks. You don't want people to have to calculate the code. They can just manipulate the code with sliders. We got stocks and puts. We got 3D maps in Plotly for regression plane with categorical variables. And then finally in the bottom right, you can also do mapping. And I was doing talking about randomized controlled trials in Kenya and showing a map of Kenya and how the population had been randomized. But just trying to get students into the context of the study and not just, show them the data, but show them sort of like the background to the study that we were talking about. 2 more things really quickly, one of which we work with a tool called AutoGrader. If you're a professor at another university, this is built to run on Jupyter Notebooks or our Markdown documents. It's modular, component-based. It doesn't need you to configure the server to it. We at Berkeley have Gradescope, so we run our notebooks with AutoGrader, and then we can do all the final testing in Gradescope. And it's now being built out for R. So if you're interested, get in touch, and we would love to have you use it out or try it out for a class. And then finally, I think Quantico, as I said, we'll talk about this in the future, but this is also some people at Berkeley working on Jupyter Book. Jupyter Book just got 2.0 this year. And most like Data 8, Data 100, Data 88, most of these classes at Berkeley are using Jupyter Book. They're a great way, if you're teaching in Jupyter Notebooks, to have components of that and feed into your textbook. They're a great way to have free textbooks. And we also use them for documentation extensively. So another part of my job, I do a lot of outreach to people interested in teaching data science across the country and internationally, and having Jupyter Books be the basis of the Data 8 textbook are really helpful as well. So with that, I'm going to wrap up, and I would like to turn things over to Quanticon.
Great. Okay. So thanks very much, Eric. I have to say that I think Berkeley is just such a long way ahead of the curve in terms of teaching economics and data science and open source and reproducibility. It's really amazing what you guys are doing. So let's see. I'm going to share my screen. All right. Yeah. And I guess the other thing I wanted to say is that with the Quanticon organization, people said a lot of nice things about what Tom and I have done. But although it started off with Tom Sargent and myself as the leads in the project 7 years ago or so, it quickly grew into a pretty big and yet a fairly tight team. And somehow our names have stayed front and center with the project, but it's really the contributions of a lot of people that have made it what it is. And so it's nice that I'm going to get the chance to introduce some of these people today and let them tell you about their experiences teaching in these kind of programs. So what we're looking at here, this is the quanticon.org website. And if you'd like to follow along with the pages that I'm going to show you. So top right, there's a GitHub icon. That leads you to a list of repositories. And if you click on the first repository, that's a page that we've put together for this panel session. And it gives you a link to the speakers and also a little bit of information about the kind of things that we're going to cover. So what I'll do, I'm going to keep my talk pretty short. Main reason being is that I haven't had a lot of experience teaching in undergraduate programs in the last 5 years or so, and the other people in the panel have had a lot of experience. So I'm going to keep my remarks pretty brief, and I'm going to focus mainly on infrastructure and how we organize and publish our lectures. And I'm thinking that at least some of this stuff is going to be useful to people listening in, particularly the information related to Jupyter Book, which was something that Eric mentioned towards the end of his talk. So let me, let's see, what will I do? So let me first jump to the lecture series. And so this is quanticon.org/lectures. And if you look here, you see a bunch of different lecture series. There's one towards the bottom called quanticon.datascience that other people on the panel are going to be talking about. So I'll put that aside for the moment and show you some of these other lecture series. And let's take a look at the second one down. This is quantitative economics with Python. And if we click on this, we can see that there's quite a lot going on. We've got a full set of downloadable Jupyter notebooks. We've got a PDF version of the lectures, which is generated through LaTeX from the same source files that we use to generate the HTML version. And then we've got the HTML version itself, which looks something like this. So you can see, even in this one lecture series, there's an awful lot of lectures. It's just almost frightening how quickly they pile up. And that does create a maintenance burden. And that's something that I wanted to talk about, because I think other people will experience the same thing as they start to build up their lecture series when they're teaching this kind of material. But let me quickly show you one of these lectures. So if we look at the first lecture in this series, it's called Geometric Series for Elementary Economics. And this is aimed at undergraduate students, whereas a lot of the other material is more aimed towards graduate students. But if we take a look at this page, it looks very much like a Jupyter notebook in terms of the presentation. But actually, what this is created with is text-based source files, which we can take a look at. So if I click on View Source here, and I'm going to click on Raw. So you can see a text-based source file. This is written using something called restructured text. Restructured text is part of the Sphinx documentation project, which is a big part of Python documentation. And we find that it's almost essential for us to work not entirely with Jupyter Notebooks, but rather with a text-based source. And the main reason for that is that we've got a lot of material and we really want to version control it because we're collaborating with a large decentralized team. And so there's a lot of edits going on from different people. And therefore, and look, I know you can version control Jupyter Notebooks themselves, but there's no substitute for raw text when it comes to maintaining these kinds of large quantities of source files. So that's the way this is written. And then we use Sphinx to generate HTML. And then we're using an add-on to that, which is an in-house Quanticon, well, that's open source, a Quanticon product, if you like, to generate the HTML and the downloadable notebooks. And then from there, we can go to things like, if you click on this launch notebook, it'll take you to a version of the downloaded notebook that's saved in Google Colab. And then you'll be able to execute that in Google Colab, assuming you have a Google account. So lots of kind of fun things going on here. We've got execution tests. So when you have a whole lot of code, which you end up having embedded in your lectures, and then time goes by and people work on it and other people work on it and libraries change, in the end, things are getting broken. And so we're very keen to have testing associated with generation of the website and the downloadable notebooks. And so that was built in. And so we kind of went ahead and built all this infrastructure, and we had help from people like the Sloan Foundation, which was great. And there's a guy on our team called Matt McKay, who I can put people in touch with if you're interested. And he's done most of the back end of building out this infrastructure. And anyone who's interested in using this, you know, it's all open sourced, and we're delighted that other people will find value from it if they do. But having said all that, we're mainly now shifting over to something that Eric mentioned, which is this Jupyter Book project. And that's something that we've been involved in, not from the start of Jupyter Book. So Jupyter Book was initiated by Chris Holgraf at Berkeley, and he's part of the Jupyter team. But we got in touch with him and the Sloan Foundation again, and they supported a kind of big round of development of Jupyter Book. So this is the Jupyter Book 2.0 that Eric mentioned. And also a larger umbrella organization called Executable Book Project. And that's allowed for pretty rapid development of Jupyter Book. And the main thing, I guess the main message that I wanted to pass on is that if you haven't had a go with Jupyter Book, then we're in the process of shifting all our material over to Jupyter Book, and we're really excited about it. And so let me just show you really quickly a bit of material that's created using Jupyter Book and give you some idea of why we think that you find it valuable. So again, if you look at individual lectures here, let's look at this Kolmogorov backward equation. So this is one of our lectures, and if you scan through it, again, it looks very much like a Jupyter notebook, but you'll see that there's these additional publishing features. So I've got something here this is an algorithm, and moreover, it's a numbered algorithm, algorithm 6, and I can cross-reference that from anywhere else in the lecture series. So if I want to refer back to, so this is a Markov chain that's generated using algorithm 6, then people can immediately jump back to it. And when you have a large amount of material, these kind of things like, you know, numbered equations and numbered lemmas and numbered theorems, numbered examples that people can click back across, and then also publishing features like, you know, bibliographies that you want to be consistent across the Jupyter notebooks. So the reason that you get into using Jupyter Notebook is that you want to use some of these extra publishing features, and you have a lot of, or a significant number of lectures. And yeah, so there's a couple of points. I guess one thing is that it's very easy to get started with Jupyter Book. And what you need is, let's say you have a set of Jupyter notebooks, which you probably do have if you've been teaching this kind of material. Maybe you've got 10 Jupyter notebooks. What you can do is you can put them in a folder, and then you can pip install Jupyter Book. And then you edit the table of contents file for Jupyter Book and run it over the lectures, and it will immediately produce for you something like this. And now you've got a website as well as your notebooks. And in addition, you've got PDF output. And we've also got other features that are coming into play. But on top of that, as I was saying, when you've got a lot of notebooks, having a text-based representation of your source files becomes increasingly important. And previously, we'd been using restructured text, as I mentioned before, which is kind of nice because it's powerful, but kind of painful because it's persnickety and fiddly, and it's really hard to track down errors. There's actually problems with significant white space. And coming from Python, I never thought I'd complain about that because I love that in Python. But in restructured text, it's a total pain. It causes errors that are really hard to find. So the text-based representation of these notebooks is all in Markdown. It's a flavor of Markdown with a few extra bells and whistles thrown in to give you some of these extra publishing features. But it makes it super easy to author and to version control and to maintain. So we're really excited to have this new tool and have played a small part in its development. And we definitely recommend that you give it a go. All right, so having said that and being conscious that I don't want to use up too much of people's time, let me go on to the next speaker. I'll be around later if people have questions on the things that I covered. But let me pass on to our next speaker, who's Pei-Fan Wu. So Pei-Fan's at University of British Columbia at the Vancouver School of Economics. And he, with some collaborators, has put together some really beautiful lectures on data science and economics that's hosted on Quantico and done some really innovative teaching. So it's great to have his discussion. I'm sure he'll have useful insights. So Pei-Fan, over to you.
Yeah, sure. Thanks. So maybe I should share my screen.
Yeah, so I need to stop sharing. No, that's new share. I need to stop share. All right, over to you.
Okay, thanks. So can you guys hear clearly? I guess so. Let me give me 1 second to move the Zoom thing somewhere else. All right. Okay, great. So thanks. I'm one of the instructors for Econ 323, which is called Quantitative Economic Modeling and its Data Science Applications. I believe its course name is similar to that, at Vancouver School of Economics, the University of British Columbia. And it's a hybrid course on both economics and data science. And we are the main course contents are basically based on Quantico data science lecture series. So to start with, it's like the structure that we the structure of the lecture series that we put is a little bit different from the other several lecture series that you can find on Quantico, which are based on more or less based on computational methods that towards, for example, solving macroeconomic models. Instead, here in the Quantico data science lectures, what we do is that we first teach the students some very basic stuff on Python, and then also some NumPy and SciPy stuff. And then we dive into pandas, and then we teach them some data visualization, data wrangling. And then in the applications part, we lay out a bunch of case studies. So like one of each is one of the examples that you can import some data that you can probably find online, and then you apply some econometric or some machine learning methods to analyze those data. So each of them are just independent units that you can run through, and these kind of form up the whole lecture series. And the one thing that I want to mention is that for the, before I forgot, is that I think for all the QuantiCon lecture series, there's a discourse forum that you can actually say ask a questions on and to post something, and then maybe one of the QuantiCon members will be able to answer your questions. So while these lecture series are public online, you can browse them and run the Jupyter notebooks. And then if you have any questions, you can actually check this discourse forum and then ask the questions over there, and we will be able to answer you. We'll report some bugs that we didn't able to find. We didn't find or something. All right. So yeah, let me actually give you a very brief introduction on what the Quantico data science lecture is about. So first of all, we will just so about the students. The students are basically, say, second year or third year econ major students. And some of them are the so-called BIE students, a Bachelor of International Economics, which is like a standalone undergrad program that's in Vancouver School of Economics. And most of them actually don't have any programming experience before. So this will be the first programming course that they have ever taken. So the prerequisites for this course are basically just to say the principle of economics and some intermediate and micro stuff. And we don't really require a lot of, say, knowledge before taking this course, because what we are going to do is just to say, let the students apply some of the knowledge that they already know to some real world problems, like to analyze some data or to say do some data visualizations, which doesn't really require a lot of, say, professional like, economic knowledge, I believe. So at the first weeks, we will just teach the students some, say, the fundamentals of Python, like the very basics, and the collections, like the lists, tuples, etc., and the control flows, like functions, loops, and all these are run in a Jupyter notebook setting with you can say set the code cells and the markdown cells to make it say clearer for them. So basically, this is so for the first 2 weeks or 3 weeks or so, the students will just say get more familiar with Python and try to find out whether this course is actually a good course for them or not. And at this stage, we didn't really set a very high standard for them, so we try to lower down the threshold so that the students can learn a programming language relatively quickly, and then they can catch up. And especially for those people who don't really know any programming before, I think this is important for them to say not to be intimidated on this kind of on all these programming related stuff. And then after that, we dive into the so-called scientific computing part where we introduce NumPy and SciPy. So when we introduce NumPy, we actually also give them a refresh on, say, linear algebra. And for the SciPy part, we basically just go over the optimization and also the probability theory related stuff, like how to draw some random numbers from some distributions and so on. And all of these, within all of these lectures, we provide very simple economic applications. Like for example, if you click on this optimization lecture, what we do here is that so here what we do is to solve a very simple Econ 101 problem that you have a Cobb-Douglas utility function and you have some budget constraints, and you are going to find out the optimal consumption bundle for two goods given the prices. So that's some problems that students have already done before in their Econ 101 course, but now we are doing that with the new tools that we have, like the SciPy optimization one. And we can also do some pretty cool visualization, like how to say make some graph to make it more intuitive, to say do some comparative statistics, and then make it more intuitive for them. And this will be like the first 1/3. Why I close it? This will be the first 1/3 of the semester. And then after that, we dive into the pandas. We introduce the pandas library for the students. And we actually spend a lot of time on that to make sure that they understand how to do some data wrangling with pandas, especially on the group by and the merge functions, because pandas is really a powerful tool so that it can, say, manipulate data in a very, in a, say, in a way that Excel or other, say, or other tools are not capable of. So for example, if you're just doing very simple tasks like a copy and paste data, you may just use Excel. But if you are going to like group by and analyze things based on the groups also, you may have to you may have to use very complicated functions on Excel, or you have to write down a very complicated VLOOKUP function, something like that. But in pandas, after you are getting more familiar with that, you can use like merge and group by and even do some time series related stuff. And for all these, along all these steps, we actually provide like data visualization examples. So here is a cool lecture saying how to, say, replicate a professional figure that's published on the Financial Times. So basically, you are using some public data, and then we teach them how to use, say, matplotlib and try to replicate a professional figure like this one. So in the very end of it, you can see that we like almost successfully replicated the graph. So the pandas part takes like about 1/3 or even more than that of the lecture time. And then for the rest of the semester, we ask the students to hand in a final project that can be based on their previous knowledge that we teach, that they learned from this class, that they can create a IPython notebook, a Jupyter notebook that can do some data analysis and some data visualization based on the things that we teach them before. And while they are thinking about this final project with that in their head, we show them some applications and we teach them some, say, machine learning related stuff. So for example, we show them some, say, lasso regression or ridge regression and some neural network related stuff. And also some more advanced tools like how to estimate the heterogeneous treatment effects, or how to estimate a nuisance function that's used in the regressions. So basically the control variables that you have may not be linear, but it can be some nonlinear functions that you don't know what the form of it is like before. So yeah, basically we just say divide them into units. And then for each of them, you can see there are some ways that we import the data, and then we do some data analysis, and then we visualize the data. We visualize the results that we have. So all of these lectures are actually held on a centralized Jupyter Hub that's like within UBC. So after you click that, if you were a UBC student, you will jump onto, say, this Jupyter Lab page where all the Jupyter notebooks are held. So you can run all the codes whenever the instructor is like going through. So you can run everything yourself. And one thing that we did is also to say, instead of fetching data online in real time, we cache all the data that we need to use to run these lectures somewhere on the AWS server, so that the students may have a more stable connection instead of using a like unstable API that some of the websites provide. And you can click this small icon here, and then you can also click on, say, PIMS or Google Colab. Those are like public Jupyter Hubs that you can use to run these lectures on. And we have, this page is like quote unquote hidden, but say you can use this link to approach to this. And we have all the problem sets associated to the lectures that we use for the Econ 323 course. And the latter half of them are like, say, they are more related to the course materials that we cover in class. And let me just say, the final thing that I would just want to mention is the students' feedbacks. So especially during this like transition to the online teaching period, the students feel like it's actually it's not very hard for them to switch to the online teaching for this particular course, because we are essentially providing all the course materials that they can run by themselves. And by setting up a Jupyter Hub here, which is centralized, that means we only need to say set up the whole environment by us instead of the students. So the students don't have to install all those like Anaconda or all those kind of things on their own machines. That actually brings a very big convenience to all of us, and it shortens the time of teaching because you don't have to tune everything for each of the students, so they can just use a centralized hub. So if there are any issues, then we can solve it once for all. So I think that's pretty cool. And yeah, I think that's, and the students' feedback are like, the lecture series seems to be a little bit much in a sense that we cover everything, but we can only dip onto every one bit, like for a little bit, because we don't really have that much time to cover everything. So I feel like a lot of students actually try to learn all these kind of stuff after the class. So they really spend a lot of time on reading on the class notes. So sorry, the lecture notes. So the last thing that I want to show is we actually showcase all the previous students' projects here. So you guys can have a look at those. And each of them are like one Jupyter notebook that you can run. And some of the students actually list all those things on their CV or their resumes when they are trying to do some job hunting. All right, so that's everything from the Quantico data science. And let me now hand over to Chase and let him talk about his experience in teaching these kind of stuff in PHBS in China. All right, thanks.
Thanks, Peifan. I'm just going to butt in really quickly and introduce Chase. And I have to say that was some really nice stuff you covered. And I particularly liked the publication quality plots that you were showing and getting the students to produce. I imagine that they really get a kick out of producing that kind of material.
Right.
Yeah, okay, so Chase Coleman, he's an economics PhD from NYU, as is Peifan, and he's now managing director and co-founder of a firm called Valorum Data. So he's a bona fide data scientist with a very strong academic background and also does a lot of undergraduate teaching. And he's also a co-author of the data science lecture series that Peifan was just showing you guys. So I'm going to hand over now to Chase. Over to you, Chase.
Yeah, thanks, John. Hi, everyone. Thanks for the QuantEcon invitation. I think it's really important to get kind of everyone who's working on data science and economics in this intersection talking. I think there's a lot of kind of benefits to scaling, and I think not talking is a good way to stop and kind of add a lot of work to everyone's plate. So I'm going to talk briefly about my experience teaching the QuantiCon data science things that Peifan just presented. And currently I'm working with Tom Sargent and Spencer Lyon to teach a class at the PHBS Business School, at the Peking University Business School. And it's been going really well. So we talked them into, I'm not quite sure how we did it, but we've talked them into giving us a whole year of teaching and 2 courses per semester, effectively. And so it's been kind of an experience in that the course that Peifan talked about was originally kind of, the person with this initial idea was Dave Backus at NYU, and it spawned a program called NYU Data Bootcamp. That was a 1-course class. We then rewrote it with more of a focus for economics with Peifan and Jesse And this is kind of another chance to rewrite this material if we had more time to talk about more topics. And so it's been really fun to kind of think how we would approach this differently. And we're really excited to hear about how many other people are working on similar courses that, we've seen some of them and we haven't seen others. And I hope people feel free to reach out and ask questions and say, hey, you did a good job with this, or hey, I have this notebook that looks better than yours, use it. We love feedback. So this crowd isn't one that I have to convince is kind of, I think economists make some of the best data scientists. So, I'm mostly talking to economists, so people aren't going to take issue with that. And a lot of this reason is that economists are taught kind of a mixture of history and mathematics and statistics. And kind of this combination of skills. I read an article that kind of talked about this, and I couldn't find that article for the life of me. But anyways, this combination of skills, I think, really allows economists to perform this empirical work to determine whether results are sensible or not. And then they're in a place where they can tell a story about what's happening and kind of talk through either causally or anecdotally why something might be happening. There's currently lots of hiring of economists at tech companies, and lots of the people being hired at these tech companies are kind of working either directly with the data science teams or they're working kind of tech adjacent. So one reason that I think economists make particularly good data scientists is a story that a friend of mine told. So this friend of mine has kind of a mixture of a statistics and economics background, and he's originally from Australia. And he was telling me that he has a friend who runs a data science consulting firm and managed to get a job consulting with one of the biggest companies in Australia, a cigarette company, actually. And what the cigarette company wanted, which may not surprise you, is that they wanted to sell more cigarettes. So they were willing to take kind of a slightly lower profit in the short term, as long as there was higher consumption, and kind of there's health reasons and profit reasons why they would be willing to take kind of a profit cut in the short term and kind of profits longer term. So this data scientist goes out into the world, he's given their data and he starts analyzing it. So, he takes 6 months with his team and he comes back and he makes the following recommendation. He says, if you want to increase your cigarette sales by 5%, you should raise your prices by 7%. And so kind of if someone has taken Econ 101, they look at those results and they think you're crazy. And so just kind of the simplicity of having economics, having this framework to think about the world, would tell you immediately that your data was telling you something that shouldn't be true. And so I don't know what the company did, but kind of the answer he gave was almost certainly not the right one. So the course we're teaching at PHBS right now has kind of your standard analytical tools. So we're doing some mathematics, we're doing some economics and finance, we're teaching students machine learning, and kind of standard statistics stuff. What I think I think everyone else here is probably teaching those analytical tools. One of the things that I think gets often overlooked are some of the non-analytical tools that come from the data science and the computer science world. Topics such as kind of data engineering, knowing how to start and manage a SQL database, automated data pipelines. Payfon talked a lot about the data wrangling, software engineering, so using Git for version control. And again, this is probably preaching to the choir, kind of writing good code, having testing and continuous integration, and building good data visualizations. One of the things that we found is that lots of recent graduates of even reputable data science programs aren't exiting their master's degrees or their undergraduate degrees with all of these skills. And we kind of think that's a shame. We think these tools are pretty important. And so the trick is, if you have a 1 semester course, you certainly don't have time to talk about these non-analytical tools because you're getting people up to speed. But if you can work with kind of a broader community, we think that these non-analytical tools pay really large dividends to your students. And that's because, the data world is messy. So I remember taking my first econometrics course. I loved it. It was really fun. But every data set I saw kind of came in the shape that I was going to need it for an analysis. It came kind of completely clean. There was no missing data. And when you exit kind of your undergraduate degree or your academic degree, you find that, the data world is chaos. And so exposing students to that chaos will help them understand the urgency with which they should write defensive code. Kind of more practically in terms of hireability, we're working on a couple of teams. We're working with some teams right now, and we're interviewing candidates. And I think something like a quarter of them haven't ever heard of Git and haven't used it. And again, that's not a problem in and of itself. I want people to learn and be able to learn. But in terms of, short term, like being able to contribute to a team, we don't have the time to be teaching these students how to write Git. Additionally, there's some overlap with the students who didn't know Git and those who wrote code that violated basic style principles. So we'll see what students do at the end of this semester, but the students in our course are having their kind of being marked off. So we gave them like a 4-week grace period, but now there's certain kind of stylistic principles that I feel so strongly about that they're being marked off for writing sloppy code. So if you ever take a course from me, make sure to put spaces after commas. That one's a deal breaker for me. And then finally, these non-analytical tools are what are going to help students contribute to a broader team. And so students won't be working in a silo after their graduation. So they'll need to be able to participate in code review. Students who understand some of these non-analytical tools, things like building a SQL database, contribute to their team in kind of a diverse set of ways. And this can make them really expensive to fire, because if they're the one who manages and owns the SQL database, if you get rid of them, kind of things start falling apart up the chain. And anyways, so I don't have anything else to say other than this has been fun. I hope people will find ways to insert some of these software engineering for non-software engineers into their course programs. And I think we have someone coming after me.
Great. So thanks very much, Chase. I always enjoy listening to Chase because he's got very strong opinions about things like coding style and version control. And I happen to share those opinions. So yeah. All right. So our next speaker is Fedor Iskakov, who's a bit of a rising star in the field of structural econometrics. He's based here at Australian National University, and his work is heavily computational. He was lost in the wilderness of MATLAB for many years, but he's now come over to the Python side and using nice, open, reproducible tools to teach undergraduate students here. And some of those tools are coming from Quantico as well. So Fedor, over to you.
Thanks a lot. It's a great opportunity to be here and learn from all the great experiences. And as John said, my background is in structural estimation. And so it's great to have Chase's example, which basically says that we need economic theory to analyze data. Yay, that's what we've been trying to put in the center of our work. So I was going to talk about teaching computational methods at the Australian National University. The course that we have is called Computational Methods in Economics. And it's a bit of a catch-all course for the computational methods. It's what we call triple badge, so it's offered in the same time. And I'm going to show some of the internal pages of our system here. It's offered to both undergraduates and the graduate students. It's an elective, so it's a fairly small course. But it provides this so much needed knowledge in programming and writing code to anybody who wants it, really. But that's also been a difficulty because the courses, we had final exam just recently, as you can see. So we are in the end of semester. The course has focused a lot on programming, and you can roughly think of this as being divided into two parts, where in the first half we are going through the basics, essential Python knowledge, and introduce object-oriented programming and talk about algorithms and complexity. So we're taking a bit of a deeper view on programming as such. And then we introduced the Python scientific stack somewhere sort of towards the middle. Pandas is part of it, but we only sort of make an introduction. And visualizations, which are extremely useful, not only in analyzing data, but also in analyzing economic models. And that's the message that I'm trying to get across to all of the students. Then there is, in the middle of the course, somewhere before we start dynamic programming, there is a midterm project which is based on the knowledge that students get by that time of, and it's a fairly simple project that they work in teams on some economic setup. And then in the second half of the course, you could think that this is more advanced, and this is where the postgrad students get a sort of more value of. And here we are looking at dynamic programming, discrete dynamic choice, and cake eating consumption savings problem. And I would say that in this course, because it goes a little bit more to the basics of designing algorithms and learning about solution methods, we look at a whole bunch of ways to solve more or less the same problem. And so to illustrate that, the knowledge of computation requires one to try to match the solution method to the problem that they have at hand. I thought, what time should I stop? Is it right that I have 3 minutes before we should conclude this?
I think we're running a little bit behind schedule anyway. Eric,
Yeah.
I suppose you want to get us back on track a bit.
Yeah, you could wrap up.
All right, so let me say that this uses extensively the infrastructure that is built by Quanticon, and Quanticon is basically a textbook in this course. What else would I want to say? Having the ability to have plain text source for all of these notebooks is really invaluable. Version control for me, right, is something that really helps bringing material from 1 year to year and include more students. Now, as you probably have noticed, the learning Git and version control is an integral part of the course itself. So all our communication with the students is done through GitHub Classroom. And, we don't have a data hub as such here at ANU, but we are relying on this publicly available services. And GitHub Classroom is wonderful in that respect. So students are encouraged to have GitHub accounts, and then distribution of assignments, and that goes for weekly assignments and midterm and the exam as well, is all happening through the GitHub Classroom, which creates individual repositories for the students and facilitates automatic grading and things like that. Well, that's a short summary of what we do in terms of teaching at ANU. And just once again, I'd like to emphasize that having Quanticon being developed by people here in-house is extremely helpful resource that we have, and we're building on top of the of all the work that is being done there. Is there a minute maybe to I'm going to wrap up here.
Sure. Yeah, I think maybe it's a good idea to wrap up here. We're a little bit behind schedule, but thanks, Fedor. There's some really nice content there. I actually tried to take one of Fedor's exams because he sent it to me prior to running the exam for the students, and I think I would have got an F for it. But I was really impressed by the content there. All right, so we were to have one more speaker in Bertel Schoening, who is lurking in the background. Unfortunately, Bertel's been quite sick, and so we've had to scratch him from turn him into a passive participant.
Unless.
Did you want to say a couple of words, Bertel?
Well, I can probably just say a few words. I'm feeling slightly better now, so maybe I should just just very quickly share my screen here, and then I can say a little bit about our program here in Copenhagen. So we have just launched a program in computer science and economics in collaboration with the computer science department. So we're essentially teaching all sorts of different stuff like programming and problem solving that's taught by computer scientists, and so and not by economists. Math is taught by mathematicians, and we're trying to put together a kind of coherent program where all these things fit together. So it's not like you take one minor in computer science and one in economics. These courses are thought to be coming in a sequence where there's synergies between the different courses. So yeah, so we start with like programming and problem solving, a little bit of economics and math and statistics and so on. And then I'm teaching this course here I've just been teaching this course here in numerical methods. So that's optimization, equation solving, quadrature integration, Monte Carlo simulation, all these kind of things. But we teach it in a way where we teach it with economic examples. So one example is, we saw the portfolio choice model. They will have to, use maximization in order to find the optimal portfolio. They will have to use quadrature in different ways, or simulation methods to solve for the expected value of the portfolio, and put all these things together. And we teach this using Jupyter notebooks, for example. So here's just the set of slides I have here, and you can see this Python coding here. And what I really like about this, and this is something we're trying to maintain throughout the entire education, is that you can really create this link, one-to-one relationship between the code and the formulas in the book. And when we're doing that in the numerical methods, we're doing it in econometrics, we're trying to do it in microeconomics. So my colleague that taught introductory micro, he would have like a bunch of notebooks there, just to illustrate the simple things, when you do substitution between, pencils that are blue, pencils that are red, and, complements with gin and tonic and so on. You do that in Python notebooks. And then I've also really benefited from the Quantico in many respects, both with respect to the to get inspired and actually learn Python myself, but also you can get very easy instructions on how to install Python. You can send students to say, go have a look when you want to write your bachelor project about all these different menus of topics that you can build on. And then so I right now have a student who is working on the Agari model, and so we've really benefited a lot from those sources out there. So anyway, this is just a few words about what we're doing in Copenhagen. So I'm also teaching econometrics B, and maybe we should this is like standard Woolrich microeconometrics for cross-section on panel data. So maybe we should try to write some notebooks that we can put on Quantico or just have for ourselves. So that's kind of what we have in Copenhagen. And by the way, I'm working with Fedor and enjoying that. Also benefiting a lot from his teaching material. So I'm going to end here and not take more time.
Great, thanks, Bertel. Great to hear you're feeling better, and it sounds like a really innovative program. All right, so just about time to wrap up from us at Quanticon. The last speaker, just to make a couple of closing remarks, is Tom Sargent, who is a man who literally needs no introduction. He's a Nobel laureate in economics and also co-founder of Quanticon. I personally think the second achievement is more important than the first one, but I might be a minority of one in that aspect. All right, Tom, do we have you online?
He's here. He's a panelist.
I think I saw him. Is he a participant or a panelist?
Yeah, he's a panelist.
He's listed as a panelist. Tom, Tom, are you maybe muted still?
I'm muted. I'm here.
Okay,
I'm here.
Great. Over to you.
Sorry about that. Oh, you want me to say something?
Yes, please. Just a few
We're
closing
listening. Okay,
words.
I've been listening. I had to step out. Okay, so well, I don't know. Couple things. I know this thing's being centered at Cal, Berkeley, where I was an undergraduate. So that's makes me really happy. I'll make a confession. When I was an undergraduate, I was scared to death of math. It's a long story. I took almost none. This is like in the early 60s, and you could like, one of my teachers was Hyman Minsky, famous, and there were plenty of people in the economics department at Berkeley in those days who thought you could do economics with mathematics got in the way. The right way to do it was without math. And anyway, that's the way I was trained, and it's a long story. And in those days, computers were just starting. Anyway, it's a rough story. There were people at Berkeley I should have been taking if I had the courage. Like DeBrew was there, and Jorgensen, and Radner, and the statistics department. Things were being created. David Blackwell was there. People who were creating things, I'm with people who don't like math, who are telling me, yeah, math's no good. Well, that was really misled. So I got corrected by that. It's a long story, very painful story. I didn't take a proper calculus course until after I had tenure. I was cheating. I was faking it. But long story, some graduate students told me I had no business teaching them. I was teaching them a class. So that kind of got to me. Anyway, so I met guys like Sachursky. I met Chase and Spencer, and they kind of took me and shook me, and I don't know. So, and I got converted at kind of an old age. And the line was, there's a line in Winnow Lucas's papers. And it's a good thing for theorists to know and practitioners, is that when you're doing economics and you're writing down a model, it shouldn't just be loose talk. You should be able to write down a computer program that would simulate your model and maybe invert it and estimate it. Okay, and that's in those days that was easier said than done. But now guys like Payfon and Chase and John are like, they're doing it. So so that makes me really excited. And so I try to write, I write Jupyter notebooks, I write Python, and try my models out in Python. And it's very empowering. So I don't know. So I think this is a great project. And I think the students at Berkeley and other places, ANU, are really lucky to have got the things you have now. You know, like, but you're building on the shoulders of, like if you're a place like Berkeley, you should like appreciate the history of people. Like Naaman was at Berkeley. David Blackwell was at Berkeley. You know, you could go by the places where stuff was invented, you know, from nothing. And then like you could be an undergraduate at Berkeley and you could do calculations that, you know, in Python or Julia that those guys only dreamed of. So, but the fact that they dreamed of it is why that opened the door to us doing it today. So, is that enough? I'm enthusiastic. You know, I'm a crappy Python programmer, but and it's not because of age. It's just because, like, I don't know. It's just like aptitude. But you can keep trying. And Python and Google make up. You know, you can ask friends. There's debuggers. There's VS Code. There's all sorts of tools now that can cover up. Even a crappy Python programmer can kind of live up to Lucas's line that you know, if you're actually going to do science, you got to be able to write down if you're going to write down a model. What's a model? It's a probability distribution over a sequence indexed by some free parameters. Write it down so you can simulate it. And if you can simulate it, go to the statistics department. They'll tell you how to estimate it. And so this is all about empowering people. And even people who aren't very good at math. You can't differentiate something. Well, Python can. You can learn how to do that. Anyway, automatic differentiation, all this stuff. So what's being done now, I'm really enthusiastic about it. I'm just doing loose talk too. I'm like Minsky, but I'm talking to guys who can do Python programs. So.
Great. Thanks for those comments, Tom. I actually now really want to hop in a time capsule and go back to Berkeley in the 1960s and drop in
actually
lectures by Blackwell. And
yeah, except you know what I'm doing is I'm hanging around. You guys don't know this, but go look this up on Google. I'll tell you guys who were at Berkeley when I was there. I actually didn't know him. Bob Lucas was a history student. He was a history major and he went to Berkeley and he decided he wanted to be an economist and he started over. Another guy was Chris Sims. Okay, Chris Sims' roommate was the guy who started the dirty speech movement. Okay, so go look up the free speech movement from Berkeley from the old days. It's kind of what made Cal. It's the 60s. It's what made Cal. So anyway, those are great days.
I wonder if Lucas was a history student at Berkeley now, he might have gotten into economics by taking the data rate course.
Maybe, yeah.
Great. All right. So thanks so much for the comments, Tom. And
yeah, thank you.
Yeah. I'm conscious we've got a little bit over time, so I'm going to hand back to you, Eric.
All right. Thanks you guys. Thanks, Tom, for those comments. I really appreciate it. I would like to move on and hear from our colleague from Harvard, Greg Bruich, who has a really exciting big data class at Harvard. Greg, you ready? Awesome.
So thank you so much. And this has been a great conference. So I'm Gregory Bruich. I teach a number of classes in the economics department at Harvard. And actually data science aid at Berkeley is the inspiration for a lot of things that we do at Harvard. So it's really been a pleasure to be involved with this conference. Today I'm going to talk with you about an introductory class that I teach with Raj Chetty, as well as some related work that we've done with Amanda Baer and Andy Huziu. And so just to start, there's widespread concern that economics does not attract as large or diverse a pool of students as it should. And a natural question related to today's conference is, can the way that we teach economics be part of the solution? And so I'm going to argue that yes, it can be. And I'm going to give you some examples from our class at Harvard where we've tried to highlight the practical and social relevance of economics. So this is the class at Harvard. It's called Economics 50, Using Big Data to Solve Economic and Social Problems. It was the first class in the Department of Economics at Harvard that didn't have any prerequisites. So most other classes prior to this class had at least an Economics 10 prerequisite, which is our intro economics class. So Economics 50 truly was a new and distinct entry point into the field. And it's been one of the largest classes at Harvard every time that we've taught it, with many of those students new to economics. So about 3/4 of the class has been students from outside the Department of Economics. And exciting to us is that the class has drawn in a much more diverse pool of students than a typical economics class. So this chart shows the gender composition of undergraduate economics classes at Harvard. The department average is 38%, and Economics 50 was 49%. And Economics 50 was 49% female, compared with a 38% female department average. And so Ec 50 was the highest fraction female of any class, in fact, in the economics department. So let me give you an overview of Economics 50, and I'll also give you some examples of some of the things that we do in the class. So we try to teach the class like a lab science, where we engage students in doing economics rather than lecturing them about how it's done. And the class is organized around topics, so broad socially relevant topics such as equality of opportunity, education, criminal justice, climate change, or health. And in the context of those topics, we try to teach the students all the theoretical tools from economics and all the statistical tools from econometrics that they need to understand research in those areas. And so in an econometrics class, I also teach an econometrics class, and one big difference is the way that the class is structured. So in a methods class, we would often go through one by one. You might have a week on a particular method and then move on to a next method in the next week. And in contrast, in Economics 50, it's all organized around the topics. Moreover, to show the students that economics is a field that's alive and not just kind of an established body of knowledge, the course is based entirely on papers written in the last 10 years. And then instead of problem sets, students work directly with data on significant empirical projects where we have them do economics on their own. So we dug a little bit deeper, and we tried to determine what it was about the class that made it successful. So we systematically analyzed the course comments, and we talked with students, and we identified 5 thematic elements of the class that appear to make it successful. So I'll go through these quickly, and then I'll give you an example of one of our empirical projects that captures each of these 5 themes. So the first theme is personal connection to the material. The second theme is real world exposure, by which I mean the class pertains to topics and debates playing out in the real world. The third theme is scientific inquiry. So students appreciated that as a discipline, we don't have all the answers, and they appreciated participating in the process of scientific discovery. The fourth theme is social value. So students saw through the class how economics can be used to improve the lives of others. And the fifth theme is career value, which is learning skills that are valued by employers. So to give an example that captures these themes, I'm going to talk briefly about the first empirical project. And Eric has kindly made a Python notebook, which is linked to on the workshop website. And so the first empirical project we called Stories from the Opportunity Atlas. And the Opportunity Atlas is a freely available interactive mapping tool that traces the roots of outcomes such as poverty and incarceration back to the neighborhoods where children grew up. It was constructed in a paper by Raj Chetty, John Friedman, Nathan Hendren, and collaborators at the Census Bureau, using data from about 20 million kids born in 1978 to 1983. I'm going to switch over now to the Atlas website. And you can also go to this website yourself. It's opportunityatlas.org. And I can paste it into the chat as well. And so this is the Opportunity Atlas. And so the statistic that we're looking at here is household income measured in 2014 to 2015. And so this is when those children who were born in 78 to 83 are in their early to mid 30s. And the key thing about these data is that the map is showing you where they grew up. So many of them don't live in those places anymore, but using anonymized tax and census records, these data are able to be constructed for the locations where people grew up. And then another important fact about these data is that it's conditional on parents' income. So the statistic that I'm showing you is average household income for kids who grew up in low-income households, which is defined here as their parents were at the 25th percentile of the national income distribution back when those kids were young. And so everybody in this map, all the colors that are being shown in this map are for kids who grew up in families that had the same level of income. And so the 25th percentile is about $25,000. And if you look down here at the legend, in some of the best places in the United States, those kids whose parents were making $25,000 go on to make about $55,000. And in the worst places to grow up in America, those same kids grow up to earn less than $20,000. And what we can also do is we can type in a specific address. So I'm going to type in a specific address that corresponds to a large public housing complex in
I think you muted yourself.
Have I been muted the whole time?
No, just last second. You're good. Keep going.
Okay, thank you. So that's great. So so this is the Opportunity Atlas, and now I've zoomed into the Nickerson Gardens, which is the largest public housing project to the west of the Mississippi. And I'm showing you household income here for those kids who grew up in those low-income families. We can also change the subsetting. So I can change the group that's being displayed on this map. So I'm going to change to not the kids who grew up in 25th percentile households, but kids who grew up in the very bottom 1% of the national income distribution. And I can also condition on race and gender. So I'm switching to Black men who grew up in families at that very bottom 1% of the national income distribution. which is actually representative of families who grew up in this housing complex. And so you can see that those children only grow up to make $3,000 on average when they're in their early to mid 30s. And so, how can that be? How can it be that people could have such a low income on average? And these data are very rich because we can switch over to another outcome that sheds some light on explanations. And so you can see all these various outcomes that are listed along this left-hand side of the page, and switching over to incarceration rates, you can see kind of a striking statistic, which is that for kids who grew up in this public housing project, 44% of them were incarcerated on a single date, which was the date of the 2010 census. And so, that sheds some light on, why outcomes are so adverse in this census tract. And moreover, if we, look down over just a couple of miles to Compton, so the Nickerson Gardens is located in Watts, and just a couple of miles down in Compton, the incarceration rate for the same group, so Black men whose parents were at that bottom 1% income level, only 6.2% of those children were incarcerated. And so this is what we asked the students to do in this first empirical project, was to look up their hometown on this website and formulate a hypothesis for why they see the patterns that they do in these maps. And then what we asked them to do was use the underlying data, which are all publicly available, to try to test their hypothesis. And I'll just briefly mention that there is also now a opportunity atlas for Spain. And so for students who are maybe not from the United States, it's also possible now to start to analyze their hometowns as well. And I can also put this link into the chat. But there's an analogous data set that was constructed in the same way for those students, which we plan to use in future iterations of the class. And so just switching back to my slides, that was the first assignment in the class, was to generate a hypothesis and test it. And the specific statistical methods that the students learned here was data visualization, regression, and correlational analysis. And for many of the students in our class, remember, our class has no prerequisites. So for most of the students, it was their first time analyzing data using statistical software. And the deliverable for this project was to write up a story or narrative based on the maps that they drew and their statistical analysis, and summarize the takeaways from that analysis that then could be discussed with a policymaker or a journalist. And so this is the first project in the class, and there were a number of other projects. This was focused on descriptive data, and the other projects were focused on causal inference, and the last project was focused on machine learning for prediction. And I'll just briefly mention that as a class that has no prerequisites, often people are skeptical about being able to teach complicated methods like regression discontinuity design or regression trees. And so I think that data visualization, which has really been facilitated by big data, is something that allows us to teach these complicated methods to students without any prior training in the field. And so, the reason for that is, when you are working with a big data set, it's often enough to just plot conditional averages. So look at a bin scatter plot in a regression discontinuity design and use that as a way of teaching that method to students. And so there's a saying, a picture's worth 1,000 words. And that's the approach that we take in the class, is use data visualization in order to facilitate teaching students without any prior training in statistics or economics. And second of all, the big data, being able to split up data based on fine geographic units, and furthermore splitting that based on parents' income, race, and gender also facilitates designing assignments where students can examine their hometown or their own ethnic or gender group. And so I think big data plays a big role in facilitating the type of class that we teach. And all the syllabus, so syllabus with a extensive reading list, lecture videos, slides, as well as lecture notes and the projects with data are all available at this URL. So opportunityinsights.org/course. And it's all freely available. So we hope that that is useful to you in teaching your own classes. And we would be delighted to hear from you as well, and join with you in kind of teaching economics in this way. So why don't I end there? If you have any questions for me, my email address is on this slide, and we would be delighted to hear from you.
Awesome. Thank you, Greg. That was great. It's a really cool class. I encourage people to check out the assignments. Each one of them is like a really cool data exploration for sure. Up next is Sean McCohen, who I would say is an interesting person who started just building this curriculum by himself as a student, and then continued on and is still building curriculum in the space, but also working in the space. So Sean's somebody who's working in the area of finance, but also like building materials to teach finance at the same time.
So I will share my screen really quickly. Can everybody see that?
Yep.
Perfect. So unlike some of these people, I need an introduction, I would say. You probably are not familiar with me. Really quickly, I started school at Boston College and did finance and economics. And essentially in fall of 2016, I started this independent study and found this passion project, financeandpython.com. And, I'll talk more about that throughout this. Started full-time work in fall 2017. And then, I've done a master's from Georgia Tech in analytics. And I think I especially wanted to talk about this because, I've recently gone through a lot of what curriculum can be nowadays. The Georgia Tech program was a part-time online program, and it was amazing because I could easily do it with work. And so I just thought that was really important for maybe some of the undergraduate students to know that there are programs out there like this that are so easy to do while you work. You know what I mean? I mean, maybe not that easy, you're going to be doing a lot of work for it, but very rewarding programs. And then most recently, I'm working full-time at 74 Capital Management, which is a startup quantitative hedge fund. And also I started in spring at Columbia doing an applied math master's. And then finally, I've also taught a course over with ADEC, which is a university in France. So I'll get more into the actual projects now. And Finance and Python, what it is this website where I just really wanted to teach people both Python, but also how to use kind of finance, economics, and mathematics. So while it's financeandpython.com, it does teach more than just finance. It would have just been too much to say finance, statistics, mathematics, and python.com. So I chose one. And, the output, what I've actually created with the website is very similar to what Quantico kind of has, where it's all in text laid out there. And, I've gone through a lot of revisions, and we'll kind of go through some of the things I've learned. I think what they've said about kind of this text file thing, I totally agree. I think you need a little bit more control over your content. And I've found over time that I use a similar kind of thing, and it just helps so much more. And, I'll just give examples of some of the courses. We had Economic Foundations, which is how Eric and I actually got connected. He had found that and thought it was pretty cool. And then, I have a couple other courses, about 15 courses on there right now. And I'll go through at the end and show you guys some of the outputs of, these courses. The other project I've been involved in was machine learning for investment management with alternative data sets. And this course was part of EDEC University's investment management Coursera course. So EDEC had a 4-course certification, and I co-taught this with Dr. Gideon Ozick. And basically what we wanted to look into was, all the ways alternative data can inform finance. Now, while it is finance, a lot of this really is kind of applying to, economics. You can see under Gideon's tagline, it says financial economics, because it's really that intersection of the two that we look at in a lot of our course. So the different modules we looked at was, consumption data, so stuff like credit card data and usage, textual analysis, corporate filings, and then looking at kind of also the media derived data, because alternative data has become so huge in finance, trying to find that next edge of where you can get information to figure out where different stocks may be going. And I think this is especially interesting and helpful for maybe other people, but the structure of our modules was that we went theory, practical applications, and academic research. And I think that this kind of split of it is one of the better ways to work through, because first students are able to see a mathematical equation and understand it a little more once they actually go in and apply it within, a case study, and, they're working with the data set, and they might be applying this textual analysis theory that we just learned, but they're actually, working with the code. And then finally, when you go and say academic research, it lets these students think about all the crazy things that maybe could come after. And it's more, maybe inspiring of, well, look at what, this research showed can be done in the future. So that was kind of how we split it up. Now, for undergraduates, I just wanted to give maybe a couple tips on things. I've, only been out of college for a couple of years, and technically maybe not, because I'm, still doing master's, but at least undergraduate. And so to me, one of the things I wish someone kind of explained to me is just how ambiguous this idea of data science can really be. I think a lot of people use it sometimes as a catch-all. To me, you can have, these are just like 3 sample jobs. You could be a business intelligence analyst, and you're using Excel and Tableau, and you're making great dashboards for senior management, but you might not actually need so much coding. You could also be a big data engineer, and you're more actually focused on developing the infrastructure for massive data sets and how you handle working with data that's too big to even store on one computer. Or on the other hand, you could be a machine learning researcher, and you're applying all these machine learning techniques to try and solve problems and predict behavior. And even within, a machine learning researcher, for example, there are so many different paths and things that you could be doing. Is it, computer vision? Is it natural language processing? So I just really think that people will benefit to understand that it's a very broad term, and you may want to kind of figure out what exactly excites you within data science, not just this broad idea of data science, but which piece of it. Is it the actual, big data processing, and you're really into the development side, or are you one of the guys that or girls that just loves visualization and you actually really thrive off that? Another kind of thing that I think is really important is continuous learning in data science is extremely important. I'd say online and part-time masters are amazing. You can also kind of do these full-time masters, but I really recommend to everybody to kind of build off that undergraduate skill set if it's possible, because there's just so many things to cover. And maybe it's also because I love learning, but I really push other people towards this. There's also the massive open online courses, and these are great when you need to work on targeted skills. So to me, I think about like learning PySpark this summer was something that I decided to do, because I realized that while I haven't worked a huge amount with big data, there's probably going to come a time where I'm moving on to, huge data sets, and I need to be quicker with my big data skills. So, these massive online course providers, it's very cheap, and you can quickly build up skills very tailored to what you need. And then on the other side, I always say, you know, passion projects are the best way to learn. Not only are you going to get better at coding as you build something, but to me, my website has kind of opened more doors than anything I've done, you know, any degree, anything like that. The website, for whatever reason, people love to, you know, reach out, talk, and, you know, I've made kind of friends and connections through this. And so to me, I'm like, I always push people to do this kind of passion project. Now, in terms of, you know, speaking to everybody else kind of here, I think some people may already feel the same way or know these things, but some of the things I've really picked up on are students always ask me for video content. Whenever I get, you know, a very nice LinkedIn message saying, hey, I love your website, I always like to follow it up with like, what don't you like? Or what can I work on? And pretty much every single time they will say, I really like the actual content, but I wish it was, you know, in the medium of a video, because I would learn better, you know, watching you do it versus, you know, trying to read it. So a lot of students are visual learners. And I think for that reason, video content is something that everybody should at least kind of be considering. You know, and this video content, this is from the Coursera course I taught, because that's all video. The other thing that I think students have really talked about is they like that, you know, I work step by step, and it's not necessarily like I'll take something that maybe could be explained in 1 or 2 lines, but I'll break it out into 6 or 7, as you kind of see here in the example, because to me, a lot of times it's easy to lose students on just one tiny little step that you take for granted that they know or they understand where you got that from. So I think that's another really important thing, is breaking everything down into just a lot of different kinds of steps. And 1 second. Oh, sorry, I just wanted to make sure I wasn't missing anything. As well for community, for practitioners, I wanted to say another big thing is kind of building this community around whatever project you're working on. In one aspect, focusing on your strengths is huge. I realized very late into kind of this website, you know, I've been doing it for a couple of years, that I was wasting way too much time on things that didn't matter. So for example, I actually was really trying to learn Flask like really well, because I wanted to make things like user accounts and have it be that someone can sign in, track their progress, all of these things. And one day I actually just Googled if, you know, there was something that had already done it. And I realized just using WordPress, it was so easy comparatively. And so to me, I would say focus on what you know. You know, I'm not a web developer. I should not spend time trying to build out an original Flask application for my website. You know, WordPress was much better. I'd also say consider going open source, just because open source communities, I don't think I really need to explain this one too much to everybody, but there's so much benefit from them and so many great projects that come. That's one place I would like to take the website eventually, because I'm realizing as a one-person team, it can be very hard kind of operationally. So when I get an email that, you know, something's broken, a dependency or an API, it's really tough to maybe correct for that. And then this final note is, I would say interacting with smaller communities can be really beneficial. So the example I'm going to use is this CAD library. My old boss created a library for complex systems. And essentially, after I was messaging with him, we realized that he really needed tutorials, because it was a really new library. He had a lot of interest, but he was having trouble explaining some of the usability of it and how one gets to actually building out the simulations that he was, you know, hoping other people would eventually be able to build out themselves. So I built, you know, this tutorial for his website, or sorry, his Python library. And for them, it was great because now they got this free resource to show people. But, you know, I actually saw the most benefit on that course compared to all my other courses. You know, when I put it on social media, I probably got 10 times the amount of responses as usual. And to me, I think that's just a testament to how important it is to interact with other kind of small communities that are maybe in the similar, you know, spaces you trying to just make it. And I think you can find a lot of people who will. So I'm going to be conscious of time and see how much I can get through, but I'll give 4 kind of case studies and go through some of the notebooks, or at least just show a little bit of it. And so here's 4 different kinds of lessons. I did one being Uber trips in New York, and this was one of the Coursera notebooks. And we basically looked into geolocational data and taking that data and mapping it and looking into where the flow of people were going. We also have Excel report automation, and I think this is one of my favorite courses because of how practical it is. It's not the most interesting, but this kind of process automation piece is so important. What Chase said about kind of this fundamentals and how do you build out a data pipeline, to me, that is so important. So that course is all about taking some economic data and automatically creating a report from it. And then also there is this third one, which is corporate filings. So looking at the 10K of companies and trying to do some textual analysis. And finally, I'm going to try and maybe show my interactive option valuations dashboard. And that's from a course on Finance in Python. And that is using IPY widgets to showcase just how you can kind of really tailor some visualizations to be dynamic. So I'm going to quickly pull this up.
We're going to need to wrap up really soon, Sean.
Okay. Yeah. So I'll just I can just end in 2 minutes, but essentially the Uber one is showing kind of the heat maps and the flow of different traffic of people. The 10K, we get to work through some of the different words and find the sentiment of all of them. I'll quickly show, this is the actual dashboard that gets built out on the website. And so you can change the different options you're using, and it will automatically recreate these binomial trees. And then finally, this is kind of the output in terms of the Excel reporting. It's, click a button and it creates all the tables, all the graphs. And so those are kind of the 4 different case studies. So that's all I have. And back to you, Eric. Thanks.
Awesome. Thank you, Sean. So much material. All right. Next up is Anastasia Boris from Goldman Sachs to talk a little bit about how they're using Jupyter Notebooks as well.
Awesome. Thanks, Eric. And thanks so much for having me here. Definitely will touch on a couple of different things that people mentioned throughout the evening so far, including quite a few of Sean's actually. So good segue. So my name is Anastasia. Today, I'll give you a little bit more of a industry perspective on the application of econ leveraging Jupyter and Python. And more specifically, I'll talk about how that's done at Goldman. So I'll start with a little bit of background, and I think, instead of talking about high level, how people are leveraging these skills at Goldman, I'll give you a sense of the 2 roles that I've had here so far and some specific, hopefully interesting examples of where that mix of skills becomes extremely powerful. So I went to Harvard, wish that course was around when I was an undergrad. Seems awesome. I graduated with computer science, certainly having an interest in economics, and have been at Goldman since then. So for the first 4 years or so, I've worked on the equity derivative structuring desk. So essentially structuring different derivative products for institutional clients. So think, hedge funds, asset managers, pension funds, and helping them implement different thematic views, as well as different ways to think about risk on their books and in their positions. So I know that sounds, very high level, maybe abstract. So maybe let me showcase, what that actually means and how it ties in some of those skills with an example. So, the example I'll give is an actual analysis and construction that I did when I was back in the desk. So for that, let's rewind back to around this time 2 years ago. And a lot of people are, I'm sure I'm following a lot of trends in econ, and will probably be familiar with this, but economy was certainly a very different point in that time. Unemployment was around 3.8. We've had continual above trend growth, so it was a very tight labor market, probably the tightest in about 20 years at that point. And wage inflation has been rising steadily. And the August of that year, 2018, was the highest wage inflation has been since 09. So why was this important for people who trade stocks, and why was I looking at that? So at that point in 2018, the median company in the S&P 500, largest 500 companies in the US, labor costs comprised around 13% of total sales, right? So that's a fairly significant proportion of the median company's revenue. So accelerating wage inflation could definitely have significant implications for margins. So let's actually use that to formulate a thesis, right? So firms with low labor costs would be less exposed to rising wages and can potentially outperform firms or stocks with high labor costs during periods of accelerating wage growth, right? That's kind of high level thesis. Of course, a couple of assumptions there I'll just touch on very briefly. So how do you actually, as somebody trying to formulate this into an actual trade, what kind of analysis and what kind of companies do you look at, and how do you measure this? So one thing you would look at is what percentage of a company's revenue is due to wages that they pay. But the problem is that there wasn't really any data on wages, right? So interestingly enough, at that point in time in 2018, companies for the first time were required to report the median wage on their 10Ks. So, this ties into some of what Sean mentioned, but since the data didn't exist anywhere yet, this is something that, you could very much use Python skills to scrape through some of those filings and acquire. So, this is a point where some of those skills become really key to doing analysis like that. So can certainly be done in Excel. Many people still do in Excel, but you get a very difficult to follow spreadsheet, and that can definitely be replaced with a beautiful Jupyter notebook that people certainly appreciate much more. So once you have the data, you could combine that with revenue data, which is certainly well available. But as we mentioned, that thesis kind of assume all other things held equal. So like one example of things held equal is different sectors, right? So if I rank companies on this proportion of labor costs to their revenues, I might end up with, on one side of my trade, maybe with all technology, and on the other side of my trade, all, making this up, but let's say consumer discretionary names. So the trends in these industries can easily overpower my underlying thesis that they will move based on this acceleration in wage growth. So, you need to do a lot more data analysis and pull in a lot of external data to try to balance this out, as well as some of the other things, in order to make what you're doing actually something that's not theoretical, you could trade in the market, right? Which includes incorporating costs in the analysis, and certainly a lot of data science oriented work that can be very easily done with Python and visualized in Python versus, there's certainly other ways, but becomes much more difficult. So, hopefully that gives you a sense for how you would go from using macro and econ more generally to formulate an idea, and then take some of those Python and data science skills to actually come up with, an implementation. And that's exactly, what I was doing in that seat, and many similar roles at Goldman look at. So, as I spend the 4 years on the structuring team, the demand for Python and programmatic infrastructure has grown dramatically. And I think some of you echoed that, that's been the case at their respective universities as well, but has grown dramatically both inside of Goldman, so internal folks who wanted to use Python, as well as externally from our clients that I mentioned. So the hedge funds, the asset managers, the pension funds. So with that, I moved over to a different team inside of GS, and the focus, and this is still my focus today, is building out a Python toolkit to expose some day-to-day useful things, but also things that have been core to Goldman's IP in a Python wrapper. So this tool is called GS Quant, and I'll pop a link in the chat for those who want to check it out. It's a open source tool. So again, we mentioned, contributing to open source can be something interesting. So certainly encourage all of you to take a look. So I'll just post the link afterwards. With GS Quant, the focus has really been to grow the adoption internally, and certainly echoing a lot of the sentiment on the call here around looking to teach some technical skills to people who are traditionally non-technical. But I think using Jupyter and Jupyter Hub in particular has been huge differentiator in that, since it allows people to, get started at least running other people's code with just a single click. So we've invested a lot to build an infrastructure internally so that any internal person with the click of a button can have GS Quant, can have other commonly used packages at their fingertips with the click of a button, and easily share with their teams. And we're working towards extending that model to clients as well. So maybe very quickly, I know we're running up on time here, but want to show you just one or two quick examples of what we're doing with GS Quant. And both of these are available in the repository directly for those who want to check it out, play around.
Oh, got it.
So I'm just sharing my screen now for one of the notebooks. It's in our Jupyter Hub internally here. So I won't go into too much detail, but again, tying some of the points mentioned on this call, what we're looking at here, and this is something that a lot of traders at Goldman look at frequently, is taking a various sampling of macroeconomic data. So these are things like different currencies, rates, inflation, break-evens, gold, credit, and using some, fairly basic statistical analysis, PCA, principal component analysis, to look at how some of these factors explain how risk evolves over time. So you could both see how much of total risk all of these components explain, right? So actually a fairly small number of factors explain something like 70 or 80% of total risk. And then you could do some analysis to actually say, well, what to interpret the PCA analysis to say, what does the first component actually represent? And what does the second represent? And how has that evolved over whatever period you're interested in, right? What kind of rotation has happened? And then, take that a step further and say, well, what does that actually mean in terms of how assets are behaving versus how the PCA analysis, would expect them to behave? So from this, you could, as in a seat at a bank or at, a hedge fund or an asset manager, you could try to formulate trade ideas, right? Where there are big dislocations that might be interesting to analyze further, and are there reasons for these dislocations, or maybe this is something that can be traded. So this notebook just uses FRED data. It doesn't call any of Goldman's proprietary APIs, so something that anybody can easily run. And for those of you who are in Eric's class, we'll be spending more time with it in the guest lecture later this month. And then the second example that I'll quickly highlight is, taking that a step further and thinking about use cases for really non-technical users. We found that there's a process for getting people familiar, and a lot of people have a fear of code, and even if it's very simple and readable, just don't want to deal with code, and maybe there's a stepping stone for getting them to that point. So we've used a couple of other open source libraries. So, we mentioned IPyWidgets. This is another kind of similar library called Streamlit that really allows you to build with a few lines, wrapping a few lines of your Python code, build these, very interactive GUIs. So this is compatible with anything in pandas, any visualizations that you're using, in Seaborn, Matplotlib. So we found that this is something that can be potentially a great stepping stone for those non-technical users. So I think, to wrap up with that, just a few points that I wanted to leave with is, if you're a student, certainly a lot of the skills that are discussed today are skills that are becoming more and more in demand. So, really, I think to the extent you're interested in academia or careers in this field, really important to continue developing those. And to the extent you're interested in any of the things that I mentioned today, there's openings both for students as well as, full-time opportunities. And I'll ping a link in the chat as well to highlight where people may apply. And, if you're an educator, we've had a great partnership with Eric in Berkeley and have dropped in on a few of the lectures to show GSQuant and how we're using it here at Goldman. So certainly, to the extent you're considering similar things, happy to get in touch on that.
Awesome. Thank you, Anastasia. She is a great guest speaker. She totally gets it. She was able to make a really nice teaching notebook for our class. Thanks, everyone. Thanks. Some really great content here. It's so exciting to see all the different people's content at different levels of complexity, at different levels of, where it's targeted in the university. I think it's just super exciting to see like the richness of, comparing across what's really advanced and really complex, and then also what's really targeting at like the beginner student to get them engaged. And I think the last two talks for me is definitely like, there's such a range of skills that can be useful for grads to walk out with. There's like a range of like how these things can be applied. And it's really great to hear that as well. Like you don't need to just be the most advanced, there's a place for people doing all sorts of different levels of skills. John, do you guys want to have some wrapping up?
No, I think we've said all we wanted to say and maybe a little bit more. So thanks so much for inviting us to be part of this. It was really good fun.
Awesome. I might follow up with some of you guys individually. I love your materials, so we may be looking to steal some for our class. It's a little funny to be in a webinar because you can't see the panelists. Feel free to shoot us a question in the chat, or thanks for attending and being part of it. There's also some people out there on YouTube as well. So that's even more of the other side of the wall. I will potentially make the recording available. So if you guys want to share it in your network or, put it out there. But thanks everybody for participating. Is Quanticon going to have a workshop sometime?
Yeah, it's a good question. I mean, we used to get on the road a lot, and
yeah. Let's get on the road again.
Yeah, we did some really fun road trips, actually. Some of it was a little bit of an excuse to do road trips. And we had one right around the US. And my main mission was to end up in Austin, Texas, and have really nice barbecued ribs. Somehow we didn't end up there, but the rest of it was a big success.
Oh, if only we could travel.
We'll get there. But yeah, I think this virtual meeting was a really good idea and really interesting to learn what other people are doing. So maybe Quanticon has to think about setting up some of these similar Zoom meetings so we can reach out to people a bit more.
Yeah, I mean, the other thing where I might reach out to you guys is, with other things, we're reaching out to like professional associations and sort of like, should we present at the economics association meetings, or like, should we do a workshop there, where, so we're trying to get into the computer science and the statistical association and, those sort of like how we teach, for 5,000 computer science instructors. So potentially it could be like econ meetings or applied econ or ag econ or some subset of like econ meetings where we might want to like think about putting a little workshop together about teaching.
Yeah, those all sound like great ideas. I feel a little bit behind the curve. In fact, we've been working a lot on putting together a hard copy textbook, which seems almost prehistoric in light of the discussion over the last couple hours. But we've also, you might have heard this too, but I think some instructors feel like the material that they see online it's beautiful in that it's really dynamic, but it's also worrisome in the sense that they feel like it's too ephemeral and they'll go to teach something from it next week and things will have changed.
It'll disappear.
Yeah, so, we have had the feedback that we'd like to have hard copy versions of what you're doing. And so A, we're working on a hard copy textbook, and B, we're also with JupyterBook trying to think about making it easier to build hard copy from the same set of source files that you use to build the dynamic stuff.
Yeah, there needs to be a button in the upper right corner that's like print to PDF and send to the instant printer and deliver to my house.
That'd be nice. Yeah, hopefully we'll get there.
All right. I don't know how to wrap it up, but thanks everybody for participating and for coming. And I'm totally stimulated by all this content, and I will be following up. And my students, thank you. And thanks to the students who behind the scenes, like Sandeep, who sort of like help coordinate everything. As usual, there's a bunch of people who you don't see here who help put this all together. So thanks a bunch.